Hey guys, this is Mrs. Cutting, and this is the review packet for the Unit 1 End of Unit Assessment, but I am going to start with a crash course on what we've done with exponents. So, three things that we've dealt with exponents. The first one is area of a square. So if I just asked you to find the area of a square normally, and I told you that it had a side length of 7, we would automatically know that this other side is 7, and to find its area we would do 7 times 7 and say it's 49 square centimeters, since it's 2D and we're literally talking about how many squares does it take to make this. But when we want to write that with an exponent, we're going to write 7 times 7 as 7 squared, or 7 to the second power, square centimeters. 2, and we have 2 of those 7s, yeah, doesn't mean 7 times 2, it means 7 times 7. So then the next part is surface area of a cube. So if, we cover up a little bit more of this, sorry about that. Try again. Okay, surface area of a cube. So here's my cube. And it has an edge length of 7. So that means every edge all the way around it is 7. So if I draw that flat, it is made completely of squares, and each square is the exact same size, and I have 6 of them because I have a top, bottom, side, side, front, back, so that's 6 of them. So each square is going to be 7 times 7, which we can write as 7 to the second power, and I have 6 of them. So if I was doing this normally without exponents, I would say, well, each square is 49, so I need to do 6 times 49. But when I write it with an exponent, my 49 I'm writing as 7 to the second power, but I have 6 squares that are the same size, so 6 times 7 to the second power. Or if it makes more sense to write it the other way, I have 7 to the second power times 6, because I have 6 of them that are all the same size. Either way, I'm still dealing with area, so we're talking about square centimeters or square units. So then the last part is volume. So volume is the part that's kind of new. So volume of a cube is how many cubic units, how many cubes make up your bigger cube. So my edge length is still 7, but I'm going to show you for a second with this cube that is 4 by 4 by 4. So if I didn't already know how many cubes this was made up of, I would do 4 times 4 and find out that there's 16 cubes in one layer, and then I have 1, 2, 3, 4 layers. So I would need to do 4 times 4 is 16, times 4 is 64. So with this cube, the edge length is 7, so I would do 7 times 7, and that would just give me like 1 layer of it, and then I have 7 layers of it, so 7 times 7 times 7. And how I can write that with an exponent is 7 cubed, or 7 to the third power. And then my label is cubic centimeters, or cubic units, because we're talking about how many cubes. So we're dealing with cubic units, how many cubes. Okay, so with the review packet, I'm actually going to start on the back page, because this was the part that the most people struggled with. So the learning goal here was write the volume of a cube and area of a square using an exponent. Write an expression for the surface area of a cube. So the first one says a square has a side length of 10 centimeters. Use an exponent to express its area. So it's a square, we're talking just two-dimensional. So if this is 10 centimeters, this is 10 centimeters. So to find its area, I would do 10 times 10, but we're using an exponent, so that's 10 to the second power, and it's square centimeters. Now we're jumping to 3D. A cube has edge length of 5 inches. Use an exponent to express its volume. So this time it's a cube, its edge length is 5 inches by 5 inches by 5 inches. So to find its volume, I would do 5 times 5 times 5. So my shorter way of writing that is 5 to the third power, or 5 cubed. My little number is a 3, and I have 3 5s there. And this is volume, so it's cubic inches. Now a cube has edge length of S units. And S, it's just standing for the side length. Use an exponent to write an expression for its volume. So this time, instead of having a number, I have S. So I would have to do the side length times the side length times the side length. So that would be S to the third power cubic units. A cube has edge lengths of 11 inches. Write an expression for its volume using an exponent, so just phrased a little bit differently. So I still have a cube, still dealing with volume, so I would have to do 11 times 11 times 11, which is 11 to the third power inches, so cubic inches. Write an expression for the cube's surface area. And this was actually talking about this cube still. So its surface area, each square is going to be 11 to the second power, and I have 6 of them. So 11 squared times 6, and I'm going to label it square inches, because I'm back to surface area, I'm back to talking about a flat surface. Another cube has a volume of 7 cubed cubic centimeters. Write an expression for its surface area. So this 7 cubed is telling me that to find its volume, I would have to do 7 times 7 times 7. So that means that its side length, or its edge length, is all 7. So its surface area is going to be 7 squared times 6, because I have 6 squares. They all have an area of 7 squared. And I'm going to throw a label on there. I almost wrote CM3. Whoops, I almost messed up. All right, so then we have another part about exponents. Write out an expression for an exponent and solve. Which is larger, 5 squared or 3 cubed? So I'm going to write out that 5 squared is 5 times 5. 3 cubed means 3 times 3 times 3. 5 times 5 is 25. 3 times 3 is 9, times 3 is 27. So 3 cubed is the larger, or the greater number. Write an expression for each number, then circle the greater number in the pair. So I have 5 cubed or 6 squared. 5 times 5 times 5, or 6 times 6. 5 times 5 is 25, times 5 is 125, and 6 times 6 is just 36, so this is my bigger number. 8 cubed or 10 squared, so 8 times 8 times 8, or 10 times 10. 8 times 8 times 8 is 512. 10 times 10 is just 100. And 4 squared or 3 cubed. 4 squared is 4 times 4. 3 cubed is 3 times 3 times 3. So this is 16, or 3 times 3 is 9, times 3 is 27. So 27, 3 to the third power is my bigger number. Okay. So now I'm going to hop back to the beginning. I can identify a polyhedra as a prism or a pyramid. Each of the following nets can be assembled into a polyhedron, so that's the word for if there's just one of them. Match each net with its corresponding polyhedron and name the polyhedron. So this one has a base that's a square, and then triangles going around the outside. And this is a square, or we could say rectangular, pyramid. This has squares as its bases and rectangles going around the outside. So that is a square, or we could say rectangular, prism. This one has a triangle as its base and then triangles going around the outside. That is a triangular pyramid. This one has triangles as its bases and rectangles going around the outside. This is a triangular prism. And this one is made completely of squares, so this is a cube. All right, I can find the surface area of a rectangular prism. What is the surface area of this rectangular prism? This side, which I'm going to call the front, is 4 by 4, so this is 16. This is 2 by 4, so this is 8. And this is 4 by 2, so this is 8. And then the thing that I need to remember is that it has a front, back, a top, bottom, a side, side. So I need to double each of these. So 16 times 2, 8 times 2, 8 times 2. So 32, 16, and 16. I add those pieces up, and that's 64 square units. This one is 3 by 2 by 5. So this is 5 by 3, that's 15. This is 2 by 3, so that's 6. And this is 5 by 2, so that's 10. And I need to remember front, back, top, bottom, side, side. So 15 times 2, 10 times 2, and 6 times 2, which is 30, 20, and 12. I add those pieces up, and that's 62 square units. All right, I can find the surface area of a prism or pyramid using a net and identify what polyhedron can be assembled from the net. So what is this going to make? It has 2 triangles, those are going to be its bases, and then rectangles going around the outside. This is a triangular prism. And then find the surface area. So it has 2 triangles. The triangles have a base of 1, 2, 3, 4 and a height of 3. So my triangles are going to be 4 times 3 divided by 2, which is 6. This one is the same size, 4 times 3 divided by 2, so that's 6. And then I have 3 rectangles. This is 4 by 5, so that's 20. This is 3 by 5, so that's 15. And this one's 5 by 5, so that's 25. Then I'm going to add those pieces up. I don't need to double anything because this time I can see all of my pieces. There's nothing hidden. And all of those together give me 72 square units. This one is made completely of rectangles, so this is a rectangular prism. And my surface area, I'm just going to go through and label my rectangles. This is 3 by 4, so this is 12. This is 2 by 4, so this is 8. Here's another 3 by 4, this is 12. Another 2 by 4, which is 8. And then 2 by 3 is 6. And then I'm going to add them all up. 12 plus 8 plus 12 plus 8 plus 6 plus 6. So this gives me 20, 20, and 12, which is 52 square units. All right, one more. What polyhedra would this net fold up to make? It has triangles as its bases, rectangles going around the outside. So that is another triangular prism. And then I'm going to label the pieces of my net. So this is 10 times 5, this is 50. This is 8 times 5, this is 40. This is 6 times 5, this is 30.